Good morning, students. In this video, we are going to discuss about the memory system, module number 4 of computer organization. The topic is going to be called as semiconductor memories. In this video, we are going to see about the several organizational features of a memory system. These features have been developed to help or provide a computer system with a large as fast as a memory as can be afforded in relations to all the to overall cost of the system. Let us see about the first one, random access memory. What actually random access memory is? It's a semiconductor memory. So the semiconductor memories are available in a wide range of speed. Their cycle times ranges from 100 nanosecond to less than of 10 nanosecond. So first we will see about the introduction. In late 1960s, they were much more expansive than the magnetic core memories they replaced because of rapid advance in very large scale integration technology, VLSI technology. The cost of semiconductor memories are dropped dramatically. As a result, they are now used almost exclusively in implementing the memories. So here we are going to see about the main characteristics of semiconductor memories by introducing the way that a number of memory cells are organized in a chip. So what actually random access memory is? It's a type of computer memory that can be accessed randomly. A random access memory is the most common type of memory found in computers and other devices such as printers, etc. Every computer comes with a certain amount of physical memory, random access memory. Usually, a random access memory is referred as a main memory. A CPU or central processing unit can access this random access memory directly. Basically, the RAM, random access memory, is going to be classified into two types as a static random access memory and dynamic random access memory. Static random is nothing but a short of static random access memory. The term static is derived from the fact that it does not need to be refreshed again and again. Shortly, we can call it as an SRAM. It's a type of a memory that is faster and more reliable than the more common dynamic memories. The dynamic memory supports access time of about 60 nanoseconds, whereas the static random access memory can give access time as low as 10 nanoseconds. So next we are going to see about the dynamic random access memory. The term dynamic indicates that the memory must be constantly refreshed or it will lose its content. So a random access memory is sometimes referred as a DRAM, dynamic random access memory, which is going to be used in the most personal computers. What is the meaning of refresh? A refresh means a recharging a device with a power or information. For example, a dynamic random access memory needs to be refreshed thousands of times per second or it will lose the data which have been stored in it. Similarly, the display monitors must be refreshed many times. It may be 60 to 105 times per second. This is going to be called as dynamic random access memory. Next, the semiconductor memories may be classified as read-only memory, ROM. It's a memory on which the data has pre-recorded. Once data has been written onto a ROM chip, it cannot be removed and it can only be read. Unlike main memory or a RAM, ROM retains its contents even when the power is going to be turned off. Read-only memory is referred to being a non-volatile, whereas RAM is a volatile. And read-only memory may be classified as a programmable read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory. These are the variations of ROMs which is going to be there in the family of read-only memories. Let us see about the internal architecture of the memory chip, RAM, random access memory. Memory cells are usually organized in the form of an array in which each cell is capable of storing one bit of information. A possible structure has been given in the next slide. I'll explain about that one to you. Each row of cell which constitutes a memory word. Here, if you're going to see about this figure, you can come to understand about that. Each row of a cell which is going to be constituting a memory, a word, and all cells of a row are connected to a common line referred to a word line, which have been referred as W0, W1, W15, like that. Okay, so this is a each cell which is going to be constituted with a memory word line. So it's going to be storing the capability to store one bit data over here. Okay, so which is driven by the address decoder. So all these word lines are going to be driven by the address decoder, which is going to be an 4-bit input line, A0, A1, A2, A3 address decoder. So the cell in each column are connected to a sense bar write circuit, which is going to be connected to a sense bar write circuit with 2-bit lines, B1, B0, like that, which is going to be present over there. 2-bit lines, nothing but B0, B0 dash, B1, B1 dash, B7, B7 dash, like that is going to be get entered over here. Okay, so this sense bars write circuits are connected to the data input output lines of the particular chip as called B0, B1, B2, B3 up to B7, etc. The sense this circuits senses or read the information which have been stored in the cell selected by a word line and transmit this information to the output data line. During a write operation, the sense bar write circuit receives input from the storage and store it in the cell of the selected word. So here, if you're going to see about that, a small example have been given over here. It is nothing but 16x8 organization, which consisting of 16 words of each 8-bit. So 1, 2, 3, 4, 5, 6, like that, 7. So 8 bits of data with 16 lines, W0, W1, W2 up to W15. 16 lines are going to get present over. So this is referred as 16x8 organization. So the data input and the data output of each sense bar write circuits are connected to a single bidirectional data line that can be connected to the data bus of the computer. So here, if you're going to see about the two control lines are going to be present over there. One is going to be called as R/W bar, and one more is going to be CS, read/write bar, select chip select. So these are the two control lines which have been provided in addition to the address and data lines. So the read/write bar input specifies the required operation, and the chip select input selects a given chip in a multi-chip system, which have been presented in this particular diagram over here. So here the memory circuit stores 128 bits and requires 14 external connections for the address, data and control lines. Of course, it also needs 2 lines for power supply and ground connections. So that consider now a slightly larger memory circuit which can be get connected with a 1K memory cell. Okay, 1K memory cell. Let us see about this. The 1K memory cell which has a 10-bit address is needed, but there is only one data line, resulting in 15 external connections. Okay, so that we can see about the figure which is going to be constitute and 1K cross 1 format or 1K cross 1 organization. So here a 10-bit address is needed. We are going to that required 10-bit addresses divided into 2 groups of each 5-bit for row and 5-bit for column. Okay, so 5-bit each to form a row and a column address for the cell array. A row address selects a row of 32 cells, which is going to be connected from 5-bit decoder. So W0, W1, like that. It's going to be 2 to the power of 5 is going to be 32. So W0 to W31, 32 cross 32 memory cell array is going to be get connected over here. All of which are accessed in parallel. However, according to this column address, Only one of this cell is connected to the external data line by the computer multiplexer, output multiplexer and input multiplexer. Commercially available memory chips contain a much larger number of memory cells that can we can use a small example to make the figure easy to understand. A large chip have essentially the same organization, whereas we can design our own data as 4 memory bit as 512k cross 8 organization, in which cases what happens, 19 address lines and 8 data input output lines chips may be get needed over there. So the chip capacity of hundreds of megabits are now available, which are going to be useful for us to understand or to come across with the more memory spaces.